Hello and welcome. My name is Andy Erickson. I'm a research associate at St. Anthony Falls Laboratory and the University of Minnesota. Today I'm going to be talking about the challenge of maintaining stormwater treatment practices. And this is really a synthesis of recent research and practitioner experience on filtration, infiltration, stormwater ponds, and permeable pavement practices. Before we get into the topic though, I want to draw your attention to our Stormwater Updates newsletter. This is an email newsletter that goes out a few times a year talking about stormwater research projects from the University of Minnesota. You can find out more about Updates newsletter. You can find past issues as well as project reports and other project publications on our website shown here. We also use our Updates email newsletter to announce our Minnesota Stormwater Seminar Series events. This seminar series brings nationally recognized experts in advanced stormwater innovation and green infrastructure to share their knowledge with us. And we pair them with local Minnesota experts on a panel discussion to cover the topic. As you can see on the slide here, we've had a host of great experts to give keynote presentations. And you can see future scheduled events on our website shown here for the Minnesota Stormwater Seminar Series. You can also find recordings of past events on our YouTube channel by searching for Minnesota Stormwater Seminar Series or noting the link on your screen here. Our topic for today, though, are stormwater treatment practices. And these practices go by many names: best management practices or stormwater control measures, and a host of acronyms, as you can see on your screen, such as SUDS, WSUD, LID, GI, and any other host of acronyms. The challenge we're finding in industry is that there is a plethora of new stormwater treatment practices being developed, it seems, every year, or enhancements or amendments to existing stormwater treatment practices. But the primary questions remain: do these practices work, which is a function of their design and their construction? And the other half of that question is, will they work in the future, which is really dependent on the maintenance? Arguably, no practice will work indefinitely without the appropriate maintenance. To understand maintenance, we must talk about the components of maintenance. And we believe maintenance is a pyramid in which the foundation is routine maintenance activities. These activities occur on a regular and relatively frequent basis, and they include things such as visual inspections and capacity testing, removing litter and debris, and maintaining the vegetation or ground cover. These things will happen on a regular basis, meaning once a week, every couple weeks, maybe a few times, or once a month, or a few times a season. The next level up from this routine maintenance is non-routine maintenance. These activities occur on an irregular basis and relatively less frequent than routine maintenance activities. What I mean by irregular activities is that they are happening as needed. So these activities include removing sediments and cleaning out trees, repairing structures, or partial rehabilitation of the practice itself. We would not go out to replace a structure unless it was broken. And ideally, we're not replacing our structures on a regular basis, such as every year. They are only occurring on an irregular and relatively infrequent basis. If we combine our routine and non-routine maintenance activities, we get preventative maintenance. And we call this preventative maintenance because we are trying to prevent major maintenance activities. Major maintenance, the pinnacle of the maintenance pyramid, are complete rehabilitation or rebuilding of the practice. And we want to prevent this because they are often on the same order of magnitude or even more costly than the original construction costs for these practices. So we want to prevent those as often as we can. So with that understanding of maintenance, we can now look at some of the new challenges because of the new stormwater treatment practices we identify in the industry today. The first category are filtration practices. Now, these are common practices, and their primary purpose is to remove particles by filtering or sieving through a granular media. And the common maintenance activities include removing accumulated sediment trash and debris, and measuring the filtration rates to ensure that we are treating the right volume of stormwater runoff. But some of the new challenges and the associated maintenance recommendations for these practices relate specifically to the many additives that are being amended into our filter medias today. These additives could be proprietary products, or they could be non-proprietary products that are mixed in with the media to enhance their performance. Most commonly, they're added to capture dissolved or soluble components of specific pollutants, such as phosphorus or nitrogen or metals or PAHs. Now, the challenge with these additives is that it's difficult to determine how much capacity is remaining for these additives. So we have some recommendations to collect a soil sample, have it analyzed for your pollutant of concern to determine the capacity or the amount that is there, which can be compared to the capacity, or performing simple jar tests or batch tests to determine the amount of capacity that is remaining. Now, specifically for proprietary products, the absorption capacity or the limit is typically readily available. And so it can be easy to compare and determine, based on how old the practice is today, how much capacity you have remaining for the future. For infiltration practices, their primary purpose is again to remove particles by filtration and settling, but also to reduce the runoff volume by infiltration and percolation into the groundwater. Common maintenance activities include removing the accumulated sediment, litter, and debris, and maintaining or cleaning out the pre-treatment practices. But some of the new challenges that we've seen with these practices is the large number of infiltration practices with limited infiltration, even immediately after construction. And that's typically caused by poor siting. And unfortunately, there are very limited tools to help us site our infiltration practices better. Fortunately, Nick Tecca, a PhD candidate from the University of Minnesota and St. Anthony Falls Laboratory, is working on that exact topic. And within the next year from this recording, we'll be coming out with tools. So I encourage you to sign up for Updates newsletter to find out when those tools are released. With better siting tools, we can have better performance of our practices for infiltration specifically from day one. Other maintenance activities, though, require maintaining the vegetation cover, not only the cover itself, but the health and diversity of that vegetation, because those maintain the pores at the surface and prevent clogging at the surface by accumulated sediment, and also provide the benefit of deterring vandalism, which can be very important in our urban landscapes. If necessary, you may need to disc or aerate or otherwise dethatch the vegetation if the vegetation has created a coating or cover that becomes permeable or less permeable or impermeable. And in some cases, you may need to take these practices offline so that you can reseed them or plug them to restore that vegetative cover. For permeable pavements, our primary purpose here is to, again, to remove particles by surface filtration and also reduce the runoff volume by infiltration and percolation. Common maintenance activities for permeable pavements is vacuum cleaning of the surface. And it's important not to use brush sweepers on permeable pavements because they can actually drive the particles further into the pavement and cause clogging worse than it was before. But some of our new challenges and associated maintenance with these practices has actually been the occurrence of collapsed or clogged pores, specifically in the wheel tracks of these permeable pavements. In the slide picture here, you can actually see ice forming in the wheel tracks of this parking lot because those areas are impermeable compared to the permeable surfaces that are immediately adjacent. So it's important to measure the surface infiltration rates in multiple locations across the permeable pavement surface to identify where you might have clogged or collapsed pores. You can restore the infiltration rates there by intense vacuum cleaning of the surface. And that may require multiple passes with vacuum sweepers or regenerative air sweepers. You can also mill the top 1/2 to 1 inch of the surface to remove that clogged layer and restore up to 90% of the infiltration capacity. However, we do not want to overlay that surface with clean pavement because the binder itself or the pavement could clog that surface. So this is a really experimental technology and concept, and it's something that we need to use with caution and really try our best practices to understand what will work best. We've also identified in some of our newer practices, specifically with block systems, that we may need to restore the grade in block systems. However, in some situations where they are not cable tied, that can be relatively easy to do on a block by block basis. So I encourage you to try that to restore the grade to get a nice smooth surface on your permeable pavements. Now, there are many, many more recommendations. There are full recommendations, including frequency and what you might need to know specifically for these maintenance activities within the publication that this presentation is based upon. This is an open source publication within the Journal of Sustainability. It is a special issue on stormwater issues. And I encourage you to check out that publication for the full details and more information on maintenance and new challenges. Now, you may have noticed I neglected to talk about stormwater ponds. And that's because I'm going to now invite Vinny Taguchi to give you all the details on the complex maintenance recommendations for stormwater ponds. So with that, I will turn it over to Vinny. Vinny?
Thanks, Andy. Hello, my name is Vinny Taguchi. I'm a PhD candidate at the San Anthony Falls Laboratory at the University of Minnesota, and I've been researching stormwater ponds and how they manage phosphorus. So when we talk about stormwater ponds, you all are probably familiar with them. We actually have quite a few of them here in Minnesota. We're famous for our 10,000 lakes, but we have about 30,000 stormwater ponds. And they're a simple design. They're one of the oldest stormwater treatment practices in use, and it's basically a hole in the ground full of water. And that allows us to capture a variety of pollutants by allowing particulates in the stormwater flow to slow down and settle to the bottom and then be captured by sedimentation. And in this process, we expect a fair amount of phosphorus to be captured as well. If you all have been maintaining any ponds, you're probably familiar with some routine maintenance of managing the vegetation around the perimeter of the ponds, occasionally dredging out any excess sediment from the center of the pond or the delta by the inlet, and maintaining those inlet and outlet structures. But if you've been out to any ponds this past summer, you're probably familiar with more of this appearance, really dense, rich biological growth. And that is evidence of high dissolved phosphorus in your water. Now, these ponds are meant to capture phosphorus, so at first glance that might not seem like a problem, but if the phosphorus is in a dissolved form that's accessible to biological growth on the surface, that means that that phosphorus can be flushed out of the pond anytime you get more rain coming in. And that phosphorus can then move downstream to a lake or a river that's being protected. So a well-functioning stormwater pond should actually not have much phosphorus in the water. All the phosphorus should be stored in the sediments at the bottom of the pond. And when we have high dissolved phosphorus, that can lead to harmful algal blooms. And basically some dogs that drink that water might die, and some people who swim in it might get sick. So it's a big concern, and whether or not these algae blooms happen in the ponds or in the lakes downstream, it's something we really want to manage for. So how much phosphorus is too much? Where is the threshold between a functioning pond and a non-functioning pond? To get an idea, we took this data set of 98 stormwater ponds monitored by the Riley Purgatory Bluff Creek Watershed District in southwestern Minnesota, or southwestern Twin Cities metro area, rather. And so they have quite a spread in terms of phosphorus concentration in these ponds. And to get an idea of where our threshold might exist, we looked at some research done by Janke et al. In 2017 that tried to characterize stormwater runoff in the Twin Cities metro. And what we know from other research is that phosphorus concentrations in stormwater will tend to run along this log normal distribution. That means most of your events are going to have lower concentrations, and there will be a few outliers that have really high concentrations. So we wanted to establish a 95% confidence interval, which would be not the very lowest concentrations, but also not the very highest. We don't worry so much about the lower, so if we include that lower segment, that gives us 97.5% of all stormwater and the upper limit on that is 0.38 milligrams per liter. So what does that number mean? For reference, if we look at these other lines, the red line is our 97.5% of all stormwater should be at or below that line. The green one, according to one research study, Giblin et al. 2013, is the concentration required for duckweed to exist on the surface. And the blue line is what the state of Minnesota considers an impairment of surface waters for total phosphorus concentration. So our threshold is actually pretty conservative. The majority of stormwater should be below that red line, and most of our regulatory activities are looking at thresholds well below it. So, but even with that conservative threshold, we can see that this huge chunk of ponds, in this watershed at least, falls above our line, and that's probably where we should be focusing when we're maintaining our ponds. And if you want to look into more information on that, we've released this open access research paper that you can look up. So what do we do? Most of us weren't around when these ponds were built, or we didn't build them ourselves, but now we're being forced to maintain them. They're releasing phosphorus, and we have to meet our MS4 compliance, right? So what can we do? Well, phosphorus is pretty complicated, actually. There are a number of processes that go along that happen in a stormwater pond that can lead to the phosphorus being released out of the sediments. But most of it actually depends on whether or not there's oxygen present. So that's what we're going to focus on. And if you want to go into more detail about the science behind phosphorus getting released or not, I encourage you to look up this pre-recorded webinar that I did last year, where I go into more detail than I have time for today. But our basic recommendations, if I can summarize that, are we have to worry about pond anoxia, which is when there's not enough dissolved oxygen, and the phosphate release, the dissolved phosphorus coming out of the sediment. And the ways that we can easily monitor for that are to monitor for stratification to know how well the pond is mixing. So you can take your probe that collects temperature measurements or salinity, conductivity measurements, anything that'll let you see if there's a gradient, if there's a stratification happening in the water column. If you don't have those probes, or if you're just doing a quicker inspection, you can look visually. Is this pond likely to be sheltered from the wind? Are there a lot of trees and buildings around the edges that could stop the wind from mixing the pond? So as an example, most of these ponds that we look at here are two of our research ponds, C and D. On the left side, pond C, we see that since it's been built, this really thick vegetated buffer has been allowed to grow around it. So you can imagine there's not much wind getting through. Pond D on the right, you can see that the grass has been continuously mowed all around this pond since it was built. But this narrow band of trees has been able to establish on the very edge of the pond between the water and the grass. And that's still enough to shelter some wind. So that's something we need to be considering. And there's been research done on lakes trying to quantify the sheltering effect of vegetation. And they found that the distance across the lake that's sheltered from the shore is actually equal to 35 to 100 times the height of the tree. So for some of these ponds, 1 or 2 times the height of the tree is already the diameter of the pond. So you can imagine they're pretty well sheltered if you have that vegetation there. And so just doing this visual classification of a sheltered pond versus an unsheltered pond, we took data from 15 ponds that we've been monitoring, and you can actually separate it pretty well. So here on the left, we looked at in red sheltered ponds and blue unsheltered ponds, and looking at dissolved oxygen concentrations at the bottom. So you can see that the ponds with a lot of dissolved oxygen at the bottom are usually the unsheltered ones. There are some exceptions, but that's a big indicator. On the right plot, we look at total phosphorus in the ponds. We see that our highest total phosphorus concentrations are in the sheltered ponds, not the unsheltered ponds. So again, if you can only spend 5 seconds looking at a pond and you need to make a decision, this might be a way to start getting the right idea before we take the further step and start collecting samples and monitoring it. And if you want to look at some more information, again, this is the publication that Andy referenced before, open access, and you can see everything that's in there. So what do we do? How do we use this information about sheltering of ponds? Well, if we want to manage the wind sheltering, we have this band of trees around our pond and no mixing. One option is always to remove the trees, but you're going to get a lot of phone calls, and that's just not an attractive option. You're damaging the ecosystem. It's not really sustainable, right? So what do we do? Well, if we know the direction of prevailing wind in this region, you might be able to allow a wind corridor, just cut down 2 swaths on either end, and then the wind can move through and mix the pond. If the wind's a little more variable, or you don't really know where it's coming from, you could cut a couple of these swaths, and maybe on average your pond can mix. Now, to make that a more attractive option, you can establish some native low-lying pollinator vegetation, and then you've created a diversified habitat, you're providing more ecosystem services, and you're allowing the ponds to function as designed. So we think that's a really good idea. We still haven't had the chance to test it, but we'd love to partner with any of you who are considering this. And if you'd like to look at more information about that idea, you can look up this open access publication. So again, this is all ongoing research. We're still working on coming up with more specific and detailed recommendations, how tall the vegetation can be and placement with respect to the pond and different things like that. If you get on our email list, you'll be one of the first to know when we come out with something. So as a summary of everything Andy and I have shared here today, design and construction are very important, but so is maintenance. And you need to inspect frequently and maintain preventatively, because it's a lot cheaper to prevent a problem from happening than just fix it afterward. There are new challenges all the time. With filtration media, infiltration media, there are a whole bunch of additives in there, and we don't really know how well things work or what's best suited to a specific application. You have to worry about infiltration rates under your practice, even if you build everything to code. You have to worry about permeable pavements plugging up over time. You have to worry about wind sheltering in your ponds and phosphorus release. So we have to be really proactive here. But we've been coming up with new maintenance solutions. We can test for the capacity of our additive media. We can maintain our vegetation healthy. We can assess our ponds. We can clean up our pavement. We can rehabilitate all of our structures. So hopefully keep everything working. So with that, if you have any questions, please feel free to contact either Andy or myself, and we'd be happy to follow up with you.